Hi folks, this is number 7 from part 1 of the Unit 6 assignment. Okay, so here they're giving us two functions as a set of ordered pairs, and in part A they want us to determine the domain of f divided by g. Okay, so remember that when you're determining the domain of one of these arithmetic combinations, the first thing that needs to be satisfied is that you're taking only the x values which are in both the domain of the first and the domain of the second. So in other words, the intersection of these two domains. But because this is a division, you have that extra restriction that g of x can't be equal to 0. Okay, so if we take the domain of f, okay, now again, this will be just given as a list of numbers because you just have discrete values here, so it's not like you're taking the numbers in between these here. So the domain of f would just be a list of all the x values. So -1, okay, 1, 3, 5, and 7. Okay, same thing for the domain of g. Okay, it's just going to be the list of the x values. So we have -1, 0, 1, -1, 0, 1, and then 3, 5, 7. 3, 5, 7. Okay, so we're looking for the intersection of these two domains. So the first thing I notice here is that 0 is not in both domains, so that has to be eliminated. Whereas if I look at all the other numbers, okay, -1, 1, 3, 5, 7 is in the domain of both. Okay, but because this is a division, I have to see if any of these g values are equal to 0. And I look here and I see, well, g at -1 is equal to 0. So I have to eliminate -1 as a possible input. Okay, and I notice that g at 3 is also equal to 0. And so I have to eliminate 3 as an input. So in the end, what I'm left with for the domain of f over g is just 1, 5, and 7. So these are the numbers which are in the domain of both functions, okay, and which don't produce an output of 0 for the function g. Okay, now the second one, I'm asking you to actually determine the function. So again, f and g are not given as equations, so I'm not expecting an equation as an answer. F and g are not given as graphs, so I'm not expecting a graph. They're given as sets of ordered pairs, so I'm expecting a set of ordered pairs as an answer. So first of all, let's determine the domain of fg. Okay, we kind of did that in the first one, okay, and we realized that the numbers that are in both domains were -1, 1, 3, 5, 7. We don't have that condition that g can't be equal to 0 anymore because I'm not doing a division. So my domain is -1, 1, 3, 5, 7. So I should have as my answer now 5 ordered pairs. Now I'm not going to do this for each one, but essentially what you're doing is you're starting off. You're finding fg at -1, okay, which is defined as f at -1 times g at -1. And what's that equal to? Well, f at -1 is 1 times g at -1 is 0. So my y value is 0, so that means when I have an input of -1, the output is 0. Okay, so this would be the first point in my function fg. Okay, so it would be input of -1, output of 0. Okay, and now let me find the other ones, but I'm not going to write it all down. Okay, so here when my input is 1, okay, f at 1 is 4, g at 1 is -3, so 4 times -3, -12. So my next one, let me pick x equals 3. Okay, so here f is 9 and g is 0. So that's going to be my next point. Okay, 5. F at 5 is -2. G at 5 is 4. -2 times 4 is -8. Okay, and lastly, when my input is 7, okay, I have 0 times 4 is going to be 0. Okay, and there you have it. These are your 5 points which make up the function fg. Okay, that's it for this one.